Hi, welcome to this Open Security Summit in November 2021, where Petra and I are going to talk about our experience in developing secure multi-cloud Kubernetes applications. And we've done a huge amount of research and a huge amount of work to develop, some of our applications in this proper, clouds. It's a weird between the Kubernetes native and cloud native applications. And there's a lot of great lessons that we want to share. So I'm Dennis. I'm the CISO and CTO of Glasswall. I play very interestingly now on both the engineering and the security, and I'm very, very excited because a lot of the stuff that I'm now able to do from a security point of view is things I always wanted to do. But it helps when you can basically put a lot of alignment with engineering with the stuff that happens in security, and you also leverage a lot of the security practices to make engineering better. So I'm joined with Petra, which is one of our rock stars. She's on a massive learning curve. She's spectacular, and a lot of the stuff that she does. And again, Petra, just a quick introduction about you.
Hi, so I'm Petra Vukmirovic. Thank you, Dinis, for the glorious introduction. I'm a cybersecurity engineer here in Glasswall. And yeah, we've done a lot of work on our Kubernetes applications and Kubernetes security. It's kind of like Kubernetes, securing the Kubernetes applications is kind of our baby. So it's great to present, all this knowledge that we acquired throughout the whole process with you guys.
So what we want to do, and some of these sessions, we really want to kind of, again, start a dialogue, and we want to start to have more like panels where we also bring other, people who have experience building this. And this is a good example of something that we're not the only ones doing this, and we want to, again, learn and share our knowledge with others. So this session, a lot of it is also about laying some of the foundation of what we've done. But, any questions you guys have or things you wanted to expand, please, drop on a chat or ask during the session. So we're going to kind of start with some of the key concepts, and then we're going to go into detail on the more practical things that we've done in security. And I'm going to basically do the first sort of more engineering side of things, and then Petra is going to do kind of the second part where she almost shows a lot of what the security team is actually doing. So the thing that I found more and more is that if you want to do security, you have to do engineering, right? And I know it sounds pretty obvious, but it's, the more I look at the things that make a massive difference in a security, the more I look at core engineering decisions that ultimately security, of course, has a big driving force, but they are almost a business decision, almost like an engineering technical decision that ends up having a lot of massive side effects on how you do security. Because ultimately, one of the things we talked about yesterday, and I think is a big theme for me now, is security teams need to stop sometimes just thinking about tactical and also start to address some of the topics that we're going to address here, because the impact on the security of a product is much bigger when you can move these levers. So we're going to talk about these 5 items here, and I'm going to kind of go one by one and explain fundamentally how we build multi-cloud solutions. And let me maybe start by defining what is our definition of a multi-cloud application. So a multi-cloud application is an application that you can run independently without major changes into multiple cloud environments. We always, and we're going to cover this, you're always going to tweak a little bit to the cloud, but it's very important that the amount of effort that it takes to support a new cloud provider, it's basically orders of magnitude, several orders of magnitude, the effort to develop the thing in the first place. And this is something that I think very few products have achieved, because it's so easy to become locked into a cloud environment. And from a security point of view, that has a lot of implications as we're going to talk about it. The other thing that we've done was we also developed what we call a Kubernetes native first application. So, and what this means is it's also the same catch-22 that you have in the cloud environments, where we wanted a solution that allowed us to run this on any Kubernetes deployment. We even have the concept of BYOC, which is bring your own cluster. And again, this is very important because it's amazing how easily you get dependent on a particular flavor of Kubernetes or a particular deployment. So we've, again, put a lot of engineering work to make sure that we actually deploy this quite independently. And I'll cover that especially in the second mode. So how do you basically ultimately create this multi-cloud deployment, Kubernetes first, Kubernetes independent application? Well, you start by having very strong infrastructure as code. You basically, one of the key principles for me is the application is everything, right? The application is not just the code or a pod or even the beginning of the web service or the API that you start. The application is everything. So you need to treat everything you do from zero as code. So what it means that you need to be able to codify everything, for example, from a raw bare metal server, from an AMI or an OVA, it's basically a virtual machine, or a native cluster. So you need to be able to start from it, which is why tools like Terraform are so important. So things like Terraform and Helm charts, they are not just a nice thing to have, they are fundamental to be able to scale because they really make it much more disposable, the creation and the deployment of the service. So the first major element is to start to really codify everything so you can deploy your entire application in one go. And this is super important because you need to keep refactoring, reducing steps until you actually get it done. So that's the first major element. I'm still not fully happy with the way we test this because I don't think the testing for infrastructure as code is as mature, for example, as some of the other test frameworks, but at least we can start to do that. At least we can start to write some tests and codify some of this. But that's the first part, infrastructure as code. The second one that we've done that I found interesting because there was always sometimes some initial resistance on the need, but I found that it's probably the single biggest decision that we made that made a massive difference is to develop the entire solution that it runs in one server. One of the biggest blind spots that I think a lot of people have in Kubernetes is the idea that you need to run everything on it, right? Yes, Kubernetes is a great execution plane. It's a great place to run containers, but it doesn't mean that you need to have only one cluster or two or three. Because once you do that, they become a pet, right? They become something you have to maintain. You start to deal with side effects. And the bottom line is Kubernetes has lots of limitations, right? There's lots of things that I would expect by now to be fixed, but it's still part of the design of Kubernetes. Like it still takes a long time to create a pod. Proportionally, there's limitations on how many pods you can run. There's all sorts of limitations on how some synchronizations work. So it's very important that you're able to develop your application in a way that you remove those variables. So what we've done was from very early on, we supported 2 development modes. We basically developed a mode where you run everything, the whole application in one AMI, right? AMI is just the AWS native way of capturing a virtual image. And once you do that, you get for free, in a way, the OVA, which is basically the VMware or the more standard file format. So once you get your entire application running off an OVA, then you are independent because you can import OVAs into VMware. You can actually even import OVAs for AWS, for Azure, for all sorts of different places. You can bring an OVA with you, and so developing it for the OVA allowed us to also the AMI, i.e. the single instance, right? Allow us to have this mode where we have one cluster that now runs everything that the application needs. And this is what we call Kubernetes native. So what we mean by this, it means that you have every component that you have on your application, from databases to queues, to running pods, to services, to load balancers, to proxies, everything you need. And the way Kubernetes gives you this, right? It lives inside that one cluster. So we, for example, are able to deploy, dozens and hundreds, if not thousands, of clusters. Each cluster runs individual pods who run the individual workloads. and each of those clusters actually runs independently. So that was a very, very powerful design that we actually implemented that made a massive difference in how we operate. Let me know if you have, again, any questions so far on this. Just give me a quick second. And the next one that is also super important is to leverage the cloud native services at the end. So what we basically saying is that what we're basically saying is that when you run and when you find yourself in a cloud environment, you want to leverage the cloud environment, right? You want to, there's some services that you want to leverage, and technically, and even I'll say theoretically, right? You could re-implement your whole application just on native cloud providers. The difference is that you add them one at a time, which basically means that you really avoid a lot of the lock-in dependencies, and it really allows.
Dinis, we're losing the sound a little bit.
Change location. Hope you guys can still see me okay. Can you still see me nice?
We can't see you, but we lost the audio for a second.
Okay. Can you hear me now? Okay.
Yes.
Okay, so which part of it did you lose the audio? Well, I was talking about the leverage the cloud providers.
Yes. Yeah.
Okay. So what I was basically saying is that when you look at leveraging the cloud providers, it's very important that you do that at the end. So it's very important that it's only when you have a fully functional cluster, it's only when you have a fully functional solution, you that strategically basically ask yourself, okay, what services are better done with some of the cloud environments? A good example is, for example, load balancers, right? Load balancers are very well done in cloud environments. So that is something that you really want to leverage a cloud environment for. Other things like storage, you can deploy storage in the cloud environment. You can even deploy compute. In fact, you can even deploy cluster management in a cloud environment. The difference is that we do that after we have a whole solution. So every one of those changes is incremental, and that makes a massive difference. And that's literally what gave us multi-cloud deployments, because when you start a new cloud environment, even a cloud, the first step is actually just to deploy an AMI. Right? Okay, can we deploy an OVA into that cloud? Cool. We're now using raw compute from that. Then we look at the managed services they have. For example, when the cloud provider has managed Kubernetes, and then we implement that. And I feel that this is really the trick. The trick is if you develop something that is Kubernetes native, everything runs off Kubernetes. Not only you also have a way that you can fall back if something happens with cloud environments, which they do. Right? You actually are able to very strategically leverage the best of the cloud environment, and got to the point where, going back to the first one, is just the infrastructure of code that changes. It's almost like as part of your deployment, you then control how much of the cloud infrastructure you want to leverage. And that's fundamental, right? So that's literally how we able to develop an application where, again, if you go back to the worldly maps, we fundamentally we are commoditizing, we're productizing a lot of the multiple elements of it, and that's really what we're doing. And the full objective here is to allow the developers to code in a serverless environment. So to allow the developers to really not care when they run a pod, when they're running a service that runs inside a pod. You want the developers not to care whether this is running on Azure, an AWS, an AMI, whatever. They want to just care about the bit that they want, which kind of why I was saying that technically you could even have an expansion of this where some of the functions can even run, some of the pods eventually can even run natively as serverless functions, could run native as as Azure functions or other things, or even running something like Fargate, right, etc., right, or some other Firecracker, etc., on AWS. So it's about you then choose what component goes. And then the final element, if you look at it, the infrastructure as code allows you to create two deployment models, allows you then to add the cloud native support, but then you build security in from the ground up. And that means that we can then, for example, define a standard that applies to every single cloud at the same environment, right? And this is where the next part of this is going to come from, where, for example, like you want a case when you build an image, the same image will be deployed in every single cloud environment. When you define a particular security standard, we can then make sure that you start from a secure base, which is the one that has the least amount of variables. And then as you add the next layers, and we actually have an architecture where we actually have 5 layers, we call L1, L2, L3, L4, L5. As you add the different layers, you make sure that you don't bring your security down, right? And I think that's fundamentally our pattern for how to create these multi-cloud applications that really allow our customers to say, I want to run this in my own data center. I want to run this in my environment. I want you to put this in a separate AWS environment. I want you to run in your cluster, in our cluster, in this cloud, or can you support this other thing? We were at the point where we can say, yes, of course, right? And the amount of development or customization you need to do is actually much lower. So that's the kind of core principles on this. Let me just take a look at, yeah, so, okay, so Omer made a good interesting point, which says, if you non-log to cloud environment, you're missing vendor-specific tools that you can make things more secure, right? For example, EKS service mesh. So Omer, the idea here is that you absolutely want to leverage those, but you want to build an application where you add that as the configurations that you do when you go into a specific cloud, a particular environment. So in this particular case, we want an application that will run out of the box in all these environments. But if you have, let's say, EKS native environment, we can add extensions, or we can add that configuration so that not only you're using the Kubernetes, the managed service, you can use their native service mesh. But then that change should only be related to what is needed to make that work. Does that make sense, Omer?
Omar?
Okay. All right. Okay. So Petra, I think you can go to the next slide. So what we want to do now is we want to start going to the details. But the point that Omer asked is, I think is very important, which is the objective here is like, going back to the worldly match, right? We want to leverage the best of multiple environments. The question is the path that you go there. And the path that we found is, ironically, it's more efficient to do this way because you have much less moving parts. So it's kind of like, imagine like if we're going to add that service mesh, for example, AKS, is a big difference when you already have, for example, even if you look at the stuff I talked about yesterday on the test framework, it's very different when you have a test framework that can already, for example, stress test a server to really strong limits. And then what you then have is a situation where we go, okay, let's now introduce this little change. And let's see what is needed to make that thing work. And then you have the whole infrastructure. You know that everything else is already working. And you can really do A, B, C testing on just that little change. Because my argument would be that anything you add that is cloud native should be better, faster, more secure, more resilient, right? There should be a reason why we want to use the cloud native environments, which, by the way, fail, right? Like we have outages caused by core pieces of the infrastructure that you think should never fail and fail. And our customers don't care that, half of that AWS or Azure or whatever just went down, right? They care that their service is still working. So again, we now have a solution where if even on native deployments, we always have a backup now, right? And the backup is actually run everything, maybe a bit less efficient, but everything will still work, in an isolated way. All you need is compute. So, Petra, over to you to talk about a multiple dimension approach to secure this environment.
Yeah. So what this really is just using one of the core security principles. So basically, when you go to secure any application, you're going to think about your security principles, right? Like security in depth, using least privilege, confidentiality, availability. So you're basically going to follow you're going to choose your most important core security principles based on your use case. But in this scenario, with Kubernetes, I would say the security principles that kind of come to the front are security in depth and using least privilege. So basically, this multidimensional approach, what it really is just using the core principle security in depth. So we're going to approach this as in securing in containers, securing the infrastructure, and securing the cloud. So there is a lot of materials that you can read about Kubernetes security. So, and in this, we're not going to go through every single piece of advice to secure a Kubernetes cluster, but I'm just going to go through some kind of main pitfalls and main kind of important things to highlight here. So the first one would be secure the containers. In this scenario, so you have to basically do some sort of vulnerability scanning on your images, whether it's going to be using the native cloud ones, because like, for example, ECR has their own vulnerability scanners for the images, or also Google Cloud provides that, or you can use SNCC, you can use Aquasec, Tenable has a container scanner. The containers can be scanned through like the package managers, or it can be just read through the Docker file. And it doesn't really matter which ones you decide to go for, as long as you are keeping an eye on your vulnerabilities and making sure that no critical ones enter your system. So there is a lot of discussions about this actually, because constantly new vulnerabilities come in, and it does consume resources to keep up with your with keeping up your vulnerabilities in place, and not having any critical ones. So here's where triage becomes important. The exploitability of vulnerability becomes important. It becomes important whether a service that's affected is internal or external, because if it's more internal, then maybe that vulnerability is not really that exploitable from the outside world. It also depends on your attacker. So if you're worried about like an insider, then obviously you worry about all of it. But if you're worried, about like an external non-skilled attacker, then you don't have to put so many resources into fixing all of the vulnerabilities in regards to container images. There's also discussions of like whether we should be using like pre-hardened images. We kind of in Glasgow chose a lot of times, and Dinis can also make a comment on that. We chose the images that were right for the development, and then we went on to fix the vulnerabilities on them, just purely because that way the development stage is much more enabled and they don't have to stick to these strict rules. But we are also at the same time moving towards using, in some scenarios, pre-hardened images. So it really depends also on your use case. There will be a lot of people that will be, against using pre-hardened images. There'll be some that will say, that's the way to go. I'm curious, if anyone has any experience, please make a comment on that too. I'm wondering what you guys are doing. Also, if there's any questions or comments, please feel free to interrupt.
Just on the pre hardened image, right? It's not trivial to do that, right? Like, in a weird way, even today, it's still hard to create lockdown images, right? And that's why a CI pipeline, it's absolutely critical to do this.
Oh, yeah. Okay, so when we're securing our containers, another security principle is to reduce the attack surface. So obviously we're going to expose only the necessary services. We're going to avoid usage of standard ports, especially 8080, because that port does not, it completely bypasses any authentication or authorization. We're going to whitelist our RPs wherever possible. It's good to have separate access ports for management and user interaction. Like in case of compromise, we can close one port. Consider an identity broker for authentication. that can make your life easier. And then also like key management is quite important. And here we can also leverage the cloud provider capabilities. It just depends again on your use case. And then securing the infrastructure. So if you have a read of the CIS benchmark guidelines and you try and implement them within your cluster will pretty much be quite, the most secure as possible. So there's quite a lot of them, but the ones I want to highlight is use least privilege principle for each pod. Do not run pods as root, and use RBAC. And that's because if some pods have more privileges and they get compromised, then your whole system gets compromised. And the same goes for RBAC. It helps to reduce that blast radius. So how do we do that? There is a tool called QBench, which is open source, and it's also integrated within Aquasec, and you can use it for your scanning. We've also for one of our products, we integrate it into a pipeline so that it gets run every month, basically, to see, like, in case the devs make some kind of changes that we're not aware of as security, and that changes the findings. We get it run every month and we review it. You can even get it run less than that if you know that kind of environment is more prone to change. Also, SNCC does that too, and there's other providers that can help you scan your infrastructure for the CIS benchmark guidelines. So think about network policies as well, because you want to really restrict the communication between pods, make it only where it's necessary. Each pod can communicate with whatever pod they need to communicate with. And when you think about threat modeling, you do make sure you do that at the design phase, because any threats that you come up with during the threat modeling, it's good to implement them in the architecture of your application. So when you do think about the threat modeling, also it's important to say that you have to think about your blast radius and the trust boundaries, because you have, one thing is if a whole cluster gets compromised, and one thing is if only a container gets compromised. So as the biggest trust boundary, you have the cluster, but then within that cluster you have your nodes, you have your namespaces and pods and containers. So it's important to kind of, know their relationships, and, know, like, if any of these get compromised, what is actually the damage that's going to happen. And here you can help also by using security context and security policies within Kubernetes, so that each pod has certain, amount of privileges, not only the ones that they need to. And then, you can, the secrets, there's various ways you can approach it, but it's good to store secrets as files, and not as environmental variables, purely because you can still see the environmental variables if you do a kubectl describe pod. You can see it in the logs. You can see it even if you run a command like docker inspect. So best would be to store it in files, or leverage any cloud or third-party providers for that. Don't build them into images, because if any pod gets compromised, someone will get access to it. And obviously there is always deviations from the benchmark, because it depends on your functionality. So for example, like there's one that says, one control that says, ensure that the anonymous auth argument is set to false. That is just, we don't need that one, because we really want to enable the health check from the load balancers. So, it comes down which ones you're going to use at the end of the day. It comes down to your functionality. Or we have like our controller pod as well. Like, for example, in some scenarios, some applications are built with a pod that has more privileges just because of the functionality. It helps with speed and And that's just the way the application is run. So if everything else in your system is secure, that's a risk that you can accept. But obviously you need to be aware of it, and you need to log that risk acceptance somewhere as well and discuss it with the InfoSec team.
Yeah.
If you're going to give one pod more privileges. Sorry, Dinis. Yeah. Did you want to?
Yeah, the thing about this is also to take into account is that this is not a one-off exercise. No, the reason why ultimately you really want to make sure that security from a threat modeling, but also I would say from an architecture, has a lot of influence in some of the design is because, for example, a lot of these changes, you need multiple passes, right? You need the developers to have access to the results. It doesn't scale if the security team comes a couple of moments in time and provides this. And also there's some of these decisions that impact everything else. So if, for example, the RBAC, right? It's a good example where once you add the RBAC, so basically role-based access security, and you lock down the pods, you now force every pod to define what it needs. We kind of try to also have this practice where our pods run with that least amount of privilege as possible. So we know to be very explicit on what we need. But this doesn't happen at one-off. You break stuff. So you need this environment where, not only you can create lots of different versions of the application, which is why we need to go back to the architecture. It's so key to be able to have, for example, the full application running in an environment that it has everything on it, whether it's just an AMI or maybe 2 or 3, right? You need those environments because that's what allows you to lock down until you still have the same functionality, but you have it a lot more secure. And then eventually you get to a sweet spot where we can actually put as part of the build, which basically it should actually break the build, which is no new changes should reduce the security properties of the application. So then we make it a very conscious decision to understand exactly what the new pods or new things we're adding will change the security posture of the application. But my key point here is that you need a very good CI pipeline. So ironically, I actually think sometimes the security team needs to spend time and resources helping the CI pipeline, helping the automation, helping to make sure that the output of some of these tools are actually baked in the normal build environment, which is what makes a massive difference.
Yeah.
Over to you, Petra.
And then lastly, secure the cloud. I was kind of naughty and squeezed quite a few bits in there. So one also, thing that you can do is you can actually secure the host, so the machine image. And also there's lots of ways that you can harden it. You can use, again, CIS, you can use sticks, which is quite common in the US government, for example. They like images that are hardened with sticks. These are CISSP guidelines. And then, make sure when you do actually harden it, or if you want to upgrade your machine image, that you just don't SSH into it and upgrade it. Again, like Dinis said, this, having CI/CD pipelines, this is where it really matters, because if one node is updated, this won't get reflected with the auto-scaling into others. So it's important to have your pipelines here, and to anything that you upgrade or harden, just do it through the pipelines. So as I said, again, CIS benchmark, the Center for Internet Security really makes our life easier with all these benchmark guidelines. And you have, your IAM, least privilege permissions and roles, whether it's going to be in AWS or Azure or whichever cloud. It's important that your EC2 instance or your VM has also least privilege, only the roles and permissions that it needs. If you're going to use some kind of storage that's going to be outside your cluster, make sure it's secure. So if you're using an S3 bucket for any reason, for example, just make sure it's encrypted and there's no public access. Again, you can here use the cloud native capabilities to encrypt, data in transit using TLS and encrypt it at rest as well. And then here is where you can actually do your monitoring and alerting as well. So you can detect intrusions. Something that's, you can do it on the network level by monitoring like network flow logs, but something that's quite new and, proved to be handy with us is actually doing host intrusion detection, especially with the new IDSs that, use machine learning and behavior analysis to detect intrusions. So for example, if there's anything in the host, any abnormal behavior, suddenly some kind of application is run that wasn't before, it will alert you. And, it works on basis like if something is abnormal behavior, it will alert you, but if it isn't, it won't. So it gives you less false positives. We, for example, we have one of these kind of IDSs, and it's also quite handy because it gives us a lot of insight in the behavior of the application itself. Of course, logging, I don't even have to, talk about logging, how important it is, not just for security, but for your, application monitoring and, multi-tenancy as well. Like you obviously want to, it depends on, your finances, your customers, you want to try avoiding any kind of multi-tenancy. Sometimes, there's also Kubernetes, vulnerabilities that can come out and that, Kubernetes still hasn't patched. And at least if you have one tenant per cluster and one cluster gets compromised, doesn't mean two tenants are compromised.
So Petra, just go back to that for a second. So this is a very important concept. When I talk about an application, this is part of an application. So when we talk about deploying, for example, our application in a cloud environment, everything to do with our cloud environment, in my book, is part of the scope. So that means that it's your responsibility to also secure where you go into. So what this means, it means that if you're deploying, for example, to AKS, part of your deployment pipeline is to lock down the roles, is to make sure that everything's fine. In fact, I haven't done an application in the past where there's a health check that fails, right? If certain things are not possible, right? So you need to think about your application. Again, it's not just in this case, for example, a Kubernetes deployment, is everything that you're changing in that cloud environment. Maybe even be more extreme. Your application is everything you need to do to a default empty, for example, cloud account. So everything that needs to happen at that moment in time. So you start a complete new subscription, there's nothing there. Everything that you need to do to have a fully working, secure, lockdown, monitored, all the properties you want, resilient application, that's your application. So it's very important that when you think about the deployment and the testing and you lock down, you don't just think about the actual traditional app. You think about the whole ecosystem, which involves all of this. Cool.
Michael had a question. So from your experience, if you need to operate in a heavily regulated environment, how much can you deviate from the standard CISSP? Is that, and if that is managed through risk management? So from our experience, if you're in a heavily regulated environment, and if your customer also demands you to be compliant, obviously, you're going to try and to be as much as compliant as possible. But sometimes because of functionality, I think as long as you accept the risk and have maybe other measures to kind of make up for the non-compliant bits, then then you're fine. If you document, like for example, the DISA sticks, if you document which ones you're not compliant with and why, and I think that's fair enough. Your customer usually should accept that.
Yeah, well, that's exactly the thing. So for example, what we've done with our deployment, we have literally a presentation and we have a set of mappings that we've done where we basically list our application And we then are very clear with the customer what is our stick score and what assumptions we made, in the application. So then we can have a conversation to say, well, we don't do this, we don't do that because, for example, we need SSH, or because you need this for Kubernetes, or that's not relevant for the application. Because also there's things that we've designed the application a certain way that you don't need certain things. So I think the point here is that even that documentation should be part of your build. And actually, STIG is a good example where both the CIS and the STIG is now part of our deployment pipeline, where although we don't ship the actual STIG tool inside the virtual machine, or so the Docker containers and the environment, we then run it and we allow it to say, look, this is how you verify that we are, for example, STIG compliant to a certain level.
Yeah. Sorry. Right. So further reading. Well, I just wanted to say, basically, there's these two reading sources that you can use, and if you secure your cluster based on this, you're as much as secure as you can get. The CIS benchmark, obviously, but that's quite like a dry reading material. But there's a book called Operating Kubernetes Clusters and Applications Safely. You can download it for free from Aquasec's website. And if you go through that book and you apply all the principles from that book onto your cluster, you're as secure as you can get, and you don't need to do anything much more further than that. What's in there, because like there's a lot of things that you can read about Kubernetes security these days, but I think this is like something that I would definitely recommend as like an easy read and easy, quite straightforward implementation guideline from this. And that book also mentions the CIS benchmark and implementing that. Which, with all the tools that we have, this SNCC or Kubench, implementing the CIS benchmark controls, it's pretty straightforward. Okay, so I'm wishing you calm waters and safe sailing, and I'm going to address some questions. I think there's some stuff in the chat. All right, so let's start with right. So
I think we addressed the first one, right? With the things of using the native things. Yes, ideally, yes, you want to use all the native as you can, what's realistic and what's not. So the next one is, I think we also addressed, right? I think it was
Michael's question. Yeah. And then Chris mentioned, thank you for that, Chris. A STIG viewer is good to have, like, to check which STIG, for example, controls have been implemented. So that's a handy tool to have. And then Michael says, in terms of securing the cloud, what is a good practice to manage the software bill of materials, for example, dependencies of libraries? Is there a built-in tool in Kubernetes for this? We haven't used any Kubernetes built-in tool. We just use, purely software composition analysis tools.
So we're basically going to be using SNCC for some of those, right? And again, like I Omer, it's good that you work for SNCC. Look, we really like it, right? I think SNCC, there's a reason why it's so successful. And look, we have no commercial relationship with SNCC apart from the fact that we're a happy customer. Yeah. And I think that SNCC gets a lot of things right? And SNCC, it really helped us to raise the bar of our security, because the feedback loops and the fact that there's the pull requests directly, to the dev teams make a massive difference. And actually that thing about the bill of materials is definitely one of the areas that we're working on next, because we want to automate that. We want to also have a very good way to present that at the multiple levels for our products. Because also, I guess going to Omer's question, I think on that one, our customers are demanding that. So we want to present to our customers also, some proactive and others because they ask. This is all the bill of materials of everything we do. Which again, remember that we have now for these products, for some of these products, we have full built-in pipelines. So we actually have all the data from the Python requirements, from the npm, and also NuGet, right? So for each of the components, we can get the list from it, and but also from Snake, it gives us a lot of information too.
Yeah. Omar made a comment. I think that was a question directed to Michael, possibly. What problem are you trying to solve? Vulnerable components or supply chain attacks?
Yeah, I think that was a response to Michael. Yeah.
So yeah, Lewis made a comment. We use Trivy in the pipeline. Yes, correct. You can use Trivy. But Snake, Black Duck, and many others do the same. Yeah. So yeah, that's it. I think we've gone through all the questions, unless someone else has any other one. I hope this made a lot of sense. As I said, there's a lot of things we can talk about with securing a cluster, but mainly I think we summarized most of those things. And as long as we keep our, security in depth and our least privilege principles in mind, we can pretty much, be sure that we're securing our cluster properly.
And just going back to the original point, or the original, can you go back actually to the original 5 points of the slide? The thing, or the activities that we've done, if I take a step back and look at what did we do that makes a big difference, especially when you compare different products, or even my experience in the past with trying to build secure Kubernetes environments, is these items here. Of course, the last one, is the main one, but the other 3 ones are the ones that made the biggest difference, right? Like without these 3, everything you're trying to do in security becomes really, really painful, right? So having that CI pipeline, having that ability to deploy very effectively, having that ability to have independent versions that you can run, you can experiment, like the whole solution is disposable. That ended up being almost the pivot that allowed a lot of the security practices to occur. That's what allowed us to view security changes not as this big thing that needs to be baked in and pushed, but almost something as, the team just does as routine, and we can basically keep increasing the bar of security and almost like lowering the bar for what we accept to let through, right? So basically, this pipeline is what makes a massive, massive difference. So cool. So thanks for there's a good reference there on a chat by KubeCon about supply chain and K8s.
Yeah.
Yep, that definitely worth taking a look at that, and we'll put that on the references.
Yeah.
And good. So thanks everybody. Petra, great presentation as always.
Thank you.
And we'll put the video online, and I'm here from good old sunny Algarve. This is I like this way of participating in the summit. Might do this more often. Good stuff. All right.
All right.
See you later.